Hello, everyone, and welcome to another Open Rewrite Community Office Hours. I'm your host, Moderne VP of Engineering, Sam Snyder. My typical co-host, Tim, is busy jet-setting around Europe to a variety of exciting conferences, presenting about all the kinds of fun things we present in here normally, with the side of AI. So let's get right into it today with some announcements. If you were with us last week or have kept up with our YouTube or blog posts or anything, you've probably already been hearing about the Moderne IDE plugin, and we're going to talk a little bit more about that today and give all of you an opportunity to try it out. So let's take a look at some announcements. So there's this blog post, which we may have mentioned last time, but in case you missed it, here it is again. And this covers the functionality of the new IDE plugin, both for searching, doing code search across multiple repositories, as well as getting started with recipe authoring for being able to just click on a method directly within your IDE and generate a recipe, either refaster style or visitor based, that is going to operate on that bit of code. So check that out. And if you want to try it out, then you can get a license for a free trial of the Moderne CLI, which backs the IDE plugin here. And so that URL is bit.ly Moderne IDE plugin. That URL is very case sensitive. So and if for any reason I typed that wrong, this is the form it goes to where you could get access to the CLI. And also the IDE plugin. And when we say IDE plugin, we mean JetBrains, IntelliJ. We do not have an Eclipse plugin or NetBeans or anything like that. So this is an IntelliJ plugin. As for upcoming webinars, if you happen to miss the free webinar I did last week with No Fluff Just Stuff covering the fundamentals of recipe authoring, good news, I am reprising that presentation tomorrow. I'd like to say that it's because there was such massive popular demand that a horde of would-be recipe authors were beating down my door begging for this content, but it was mostly that we forgot to record it the first time we did it, so anyone who couldn't attend live missed it. So if you couldn't attend live last time for any reason, you can join me tomorrow in 22 hours to see that content presented live, or this time there definitely will be a recording and you'll be able to get access to that through No Fluff Just Stuff. But if you are a regular attendee of these live streams or a regular member of our Open Rewrite community Slack or Discord, I wouldn't be surprised if you already had the fundamentals of authoring YAML and Java recipes under your belt. So some of the content in here might not be surprising to regular viewers of this channel. What you may not have covered yet is on Friday, I will be giving the Migration Engineering with Open Rewrite 2 presentation, where we will get into some of the more advanced recipe authoring functionality that's available. We'll be talking more about scanning recipes, recipes that visit multiple different source files before making any changes or decisions. We'll be talking about data tables and maybe even a little touch on building visualizations off of those data tables. So if you've kind of scratched the surface on recipe authoring already, but find yourself running up against some limitations in your knowledge that might be preventing you from achieving all that you would hope to with your recipes, come join me for this on Friday, and we'll get into it there. Okay, so today I wanted to talk about a topic that is, again, very relevant to recipe authoring, and indeed today's presentation might be a good companion, I would say, to those No Fluff Just Stuff presentations on recipe authoring. So what I want to talk about today is debugging your recipes, and particularly debugging them while running them against real code, not just whatever unit tests you might come up with. Because even if you are the most test-driven of all developers and you pride yourself on your ability to consider every edge case in advance, the sheer variety of the real world will surprise you. You will find strange syntactic constructs. You will find unexpected usages of code patterns. You will find things that you thought were true 100% of the time are actually only true 99% of the time. And at a sufficiently large scale, that 1% could really matter. So we are today going to cover some common mistakes or problems people have while authoring recipes, how to debug those, and we're going to talk about how to connect your debugger, like connect a remote Java debugger to a recipe when running through the open source build plugins, as well as the Moderne CLI, which is the best way to run and locally debug recipe execution across multiple repositories. But to begin with, I'm going to search for a good example of a recipe to break. And I'm using the Moderne SAS application to do this because it is it's a very powerful code search tool that is available to all of you to use to search through open source. So in coming up with the material to present to you today, the steps I went through, I thought, well, this is something that the viewers themselves could benefit from. So let's get into it. So if you've watched this regularly, you're already familiar with this interface, but this isn't. This is something that it may not have occurred to you that you could use the Moderne SAS yourself in your day-to-day, particularly as a recipe author. Because if you are trying to author recipes, you are going to want to find examples of other recipes that are similar to the ones you're writing. If you are trying to figure out to navigate the learning curve of becoming a recipe author, becoming an expert with this technology, it's useful for you to be able to search around and find examples. So kind of the first common recipe authoring problem that I want to discuss is improperly setting up the class path of a Java template, or rather the way this manifests is in your, at least initially, is in your test case telling you that there is improper or like missing or malformed type information, is I think what I put in the error message. And so to find an example of this, I need to find, to show you how to fix it, I need to find an invocation of Java template that has something in its that has something in its class path, or that requires a symbol of some kind. So let's see. So if I go to Java template builder, what I want to find throughout the Open Rewrite code bases is examples of Java template .builder that invoke this Java parser function, because this is how the class path of a Java template parser is going to be overridden. So like anyone else who has either a public GitHub or a Bitbucket Cloud account, I'm going to log into app.moderne.io. So all of you who have GitHub accounts or Bitbucket Cloud accounts can do this yourself. This is free and open source. This is free for open source projects. You don't have to pay us anything. This is a public resource. So I'm going to log into the SAS, and because what I want to do is find examples of the usage of the Open Rewrite API, I am going to select the Open Rewrite organization from the list of organizations in the left here. So the Open Rewrite org covers all 48 repositories we have at open source and GitHub on Open Rewrite right now. And I want to find examples of this Java parser method. And so that is so I'm going to go to find method. I'm going to look for find method usages. I use a method pattern here to issue this search, and there's a document on the syntax of these method patterns. But even if I didn't remember them, I could click this little magic wand and fill in these 3 boxes rather than having to remember the syntax here. So org open rewrite.java template.builder, and the method I want is Java parser. And I don't care with any arguments. And so that fills in what I want. And let's go run this and see if I can find some Java template indications or if I did that wrong. Looks like we're getting some results. So it looks like rewrite testing frameworks could be a good place to go to find Java template invocations that override their class path. Let's see what we got here. Yeah. So, okay. So, yeah. So here, there are usages of this Java parser method, or this Java parser. Yeah, this Java parser method used on a Java template. So let's go open up rewrite testing frameworks and give this a look, so that I can demonstrate what I'm looking to demonstrate about debugging. So this is remove try catch fail blocks, for example. So let's go open up rewrite testing frameworks. And I want to check out this remove try catch fall blocks recipe. Let's take a look at this. Oh, I was not looking at testing frameworks, looking at the main rewrite repository. Let's be sure we have the latest code. And now I'm going to open up remove try catch fall blocks. And I'm going to open up remove try catch fall blocks test. So right now, all of these tests should be passing. Just run this one, make sure everything's in a good condition. Yeah, so this test is passing. So from our search result, I saw that remove try catch fall blocks has on line 121 an invocation that I'm interested in. Okay, so this test, as we can kind of see from the test, or this recipe, as we see from the test, replaces a try catch containing an assert fails with an assertions assert does not throw. And so this is the Java template invocation that generates that assertions assert does not throw method. Now, one of the most common mistakes I see from new recipe authors who are working with libraries for the first time is not setting up the class paths of their Java template invocations correctly. So let's break this in a way that a beginner might innocently stumble into and look at the consequences of that and see how to fix it. So I'm going to comment out the line that configures the Java parser used by this Java template, and in particular configures the class path of the parser used by this Java template. Now, we're still generating the exact same snippet as before. This is still syntactically valid Java code. We just are not going to put on the class path of the Java parser the, is this big enough? I should embiggen this text more. There we go. Not going to put on the class path of this Java parser the jar that implements or that provides this type, this assertions does not throw method. So now if I go and run this test again, the recipe is still going to generate the right text, but this isn't going to be type attributed, and we'll see how that manifests. So what we see now is this error, which can be perhaps frustratingly inscrutable for new recipe authors. And I should probably go in and make some improvements here so that this is more actionable. Because if you already know Open Rewrite pretty well, then maybe you know how to act on this. But if you don't, this okay, you've gotten an illegal state exception. LST contains missing or invalid type information. What do you do with that? And then there is this chain based on the cursor to say, okay, well, there's an identifier which is part of a method invocation, which is contained within a block, in a method declaration, in another block, in a class declaration, in a compilation unit. So this is trying to give you a chain to help you see the path from the thing that is the identifier that is whose type is missing or malformed, assertions, kind of from there up to the root of the document. So we see that this chain is telling us that this assertions identifier does not have type information. It is contained within a method invocation, That method invocation is inside of this block. That block is inside of this method declaration. That method declaration is inside of this block. That block is inside of this class declaration. This class declaration is inside of this compilation unit. So that's what this is trying to tell you, right? To help you figure out which assertion is or which symbol is the one missing type attribution. Okay, so now that we kind of understand what this error message is saying, what do we, how do you remediate this? Or rather, before we talk about how to remediate it, what are the consequences of this? Why am I even like putting this error in your face in the first place? Because if you see this, like, sorry, you can blame me. I created this validation. I added this to our test framework, and I didn't do it just to foil or stymie you. I did it to help prevent you from putting a malformed recipe in the world that was going to have harder to debug consequences later on. So we've talked before about the importance of type attribution to the correctness of recipe operation, right? One of the core reasons that an open reart recipe can be more accurate, more precise with the changes it makes than a regular expression is because not just the literal text you're manipulating, but what excuse me, had a burp. Not just the literal text that you're manipulating, but also the types, right? You could tell, a log for J logged at info invocation apart from an SLF for J logged at info invocation, which can really matter. And so, what this error is telling you is that your recipe is producing LST elements that are not typed, that are missing type information. Now, if you're seeing this error, like the test framework actually asserts that your recipe put out the correct text, that the LST your recipe produced printed back out to the correct text. So, like, if you write this text back to disk, there won't be anything wrong with your change. The next time your Java compiler runs, or even our Java parser runs, so long as your class path and your dependencies and everything are set up right, there won't be any problem. So if this recipe is going to produce a diff, is going to produce a patch file that is valid, why am I bothering you with this error message? Well, it's because recipes are mostly made out of other recipes, right? The way we run an individual recipe like this, remove, try, catch, fail blocks is mostly not on its own, but usually as part of a like JUnit migration or a Spring migration or a Java version migration as part of a best practices, right? It's run as part of another recipe. And there's a bunch of other recipes that are running before it, and there's a bunch of recipes that are going to run after it. And if a recipe that's running not purely on its own, but with a lot of other recipes, which again is the typical mode of operation, produces LSTs of missing type information, if there were some other recipe in that list of recipes that was going to look for this assert does not throw method to do some other transformation on top of it or produce some search result or extract some data into a data table, it would not be able to. That information would be missing. So the test framework asserts about the presence and well-formedness of type information in LST elements it produces so that your recipe will play nice with other recipes that you might run alongside it. So that's the purpose. And then the way you fix these errors is 90% of the time, 95% of the time, it's you go to the recipe, you go to the Java template invocation, and you put onto the class path of the Java parser the template is going to use to parse that snippet. You're going to put on you're going to provide the jar that provide these types to the parser, which is an easy thing to forget to do. But if you think for a second about how Java template works, it makes complete sense that this is necessary. But well, I could do that because I helped write JavaTemplate, but you might not have any concept of how JavaTemplate works. So let's talk about that for just a minute. The gist of how JavaTemplate works is you provide it this snippet of code, and you provide it a cursor, which, as we see, here, provides the kind of context of the insertion scope. It's like where you are within a source file, and we provide any imports that are necessary, any class path that is necessary to make sense of this snippet. And so what's going to happen is that around the snippet you provide, JavaTemplate builds up a valid Java source file that contains your snippet in some context where it actually makes sense, and it parses that into a full LST with a j.compilation unit, like a full valid Java source file, and then it extracts out just the bit that is interesting to you and gives that back, and does the replace of whatever you've specified with the coordinate in the apply function. So, in order to help make this make sense, and indeed to debug JavaTemplates when they are not working the way that you would hope they would, there is this do before parse template, and this is going to, you can provide a lambda here that does something with the that receives passed into it as an argument that full Java source file that's built around your provided snippet. So let's just take a look at what one of those looks like. Hi, Naz. Here's my co-presenter, Naz, here to wish me good luck during this presentation. Okay, let's go into this. So template. So yeah, let's just put a breakpoint on that so we can take a look at this template, like what is actually produced by JavaTemplate around this snippet. All right, cool. So now I've hit the breakpoint inside of the Lambda. Hi, cat. All right, now nice. Okay, so this is the snippet that is produced by this. Let's paste this into a Scratch file so we can get a better look at it. So let's see. So this is the snippet that JavaTemplate produced around assertions assert does not throw in order to do what it has to do. So you see it imports these M and these P functions, and these M and these P types. And you can go look at what these are, but these are basically, you don't have to worry too much about these. These are implementation details, and what they tend to mean is anywhere that something is going to be interpolated into the template, this is some kind of placeholder. So, if you were going to, be filling this in with an object, this P is some function that returns, that essentially is able to return type object. So we can use this as a placeholder for whatever LST element you're going to be substituting in here after the template is parsed. But you see what I was talking about before, where this assert does not throw that we're generating gets wrapped with whatever is necessary to be a full valid Java source file with the relevant imports and method and my test. And if there were variable declarations in here, then they would be included as well. So if you run into a situation where a template is not doing the right thing, go in here and check, is this a valid Java source file, right? Because if there is a bug in the templating engine, or you've provided a snippet that is invalid somehow, maybe you just made a wrong assumption or about how this was constructed, of how the source file is constructed around the snippet you provide, override this do before parse template function, take a look at what's generated. And if this is not a valid Java source file, then that hints at your next steps. And so if the templating mechanism is not working correctly, if there's a bug in it, this is often one of the most useful things you could include in your bug report, or just as part of the debugging process, is what was generated here. And indeed, we see that there's a small problem here where this is missing a semicolon in order to be a valid Java source file. this wasn't actually causing any problems that this semicolon was missing, uh, because there's the Java parser and the Java compiler to make sense of files that have some small syntactic invalidities, but your mileage may vary. Okay, so that is kind of covering how to debug, a little bit about Java template invocations, but it's maybe kind of a digression because we were talking about the the class path. So in order to provide the implementation of assertions to the template, we're customizing Java parser and using this Java parser from Java version, classpathFromResources function to grab JUnit Jupyter API 5-9. And like, where is that actually coming from? We say class path from resources, like what resources? Well, that's the resources that are included in the jar, in this case, rewrite testing frameworks itself. If we go into source main resources under the meta inf /rewrite /class path directory, this is a place where you can put jars that should be bundled in, that will be bundled in with the recipe module, and can be loaded up for use in your recipes with this class path from resources mechanism. So JUnit Jupyter API 592 in this case is here. We see this is a prefix match. What we've included is 592, and this has 59. And so this makes your jar maybe a little bit fatter, that these are included inside it when it's distributed, but this mechanism kind of makes it possible to have to migrate between multiple different versions of the same libraries, right? This is used extensively in Rewrite Spring, where you have to move from like Spring Boot 1 to 2 to 2.7 to 3, and might need, in order to template various steps in there correctly, multiple different versions of the same jars. And if you were just using the class path function to draw from the runtime class path of the recipe module, like this, then in a situation where there are multiple versions of the same library on the class path, we have all the problems that you would have with any other Java program where you had multiple versions of the same library on the class path at the same time. Which is to say, one of them wins, right? Whichever the Java runtime encounters first wins, and its version of those classes are loaded. And in a context like an open rewrite migration recipe that's going between multiple versions, that's not good enough. You really do need a specific version. So that's why we kind of came up with this class path from resources mechanism. Okay, so that's kind of how you usually fix one of these errors. Now, every now and then you will get into a situation where providing the jar that defines the symbol is not enough. And you've like, okay, like JUnit Jupyter API assertions, like this works. If I include non-project items, I can even hop to the definition here. This one works fine because everything that the Java needs to, like the built-in Java class loader needs to load this class, is provided by this JUnit Jupyter API jar. But I have run into a couple situations where if this class extends another class or implements an interface that comes from a different jar, we would need to include that too. So if you find yourself in a situation where you're like, okay, I'm trying to template something, I have provided the jar that type comes from, I'm still getting errors about messed up type attribution. Why did you lie to me, Sam? You said this was all I had to do. Well, here's the asterisk. If that class extends or implements another type, that has to be provided on the class path too, because this isn't transitive. Like if JUnit Jupyter API had other dependencies, which I don't believe it does, but if it did, JUnit Jupyter API is still all we're pulling in. And so, because it's just very literal, it's pulling in exactly what you say here. So in that case, you would have to maybe list multiple things here. I remember, yeah, this has come up a couple times and flummoxed me the first time I ran into it. So be aware of that. So if you've done all of these things, if you set up your class path as best as you can, and it's still not working, you're pulling your hair out, and you're like, look, Sam, I've heard your warning about other recipes not composing super well with my recipe if I don't have proper type attribution. But at this point, I'm fed up. I don't care. My recipe produces the right source code. I'm not worried about the exact symbol this recipe is manipulating being further acted upon by another recipe I'm working on in concert with this one. I want to opt out of this type validation in my test, like suppress this error, get it out of my face. The option is there. And the way you do that is let's break the type attribution on this again. Get rid of this. Let's break the type attribution here, and let's cancel our running test. And let's go here. And so if we're running this test again, we should be in a state where it's going to fail with missing type attribution. Yeah. So we're back in the state where we're getting the complaint about LST contains missing or invalid type information. We can turn off this type validation. This is optional. And you can do this either on the level of an individual test case or for an entire test class in the defaults method. But the way you do it is on the test spec. You call spec.type validation options, and you fill in type validation. So there's a couple options here. The default is do all validations. So this is the default. But if you want to turn off, you can turn off individual validations of class declaration, build, identifiers, constructor, all of the things that are kind of like commonly typed. So if you wanted to be really granular and be like, we're type attributing almost everything correctly, and I do want to keep as many of those validations as possible, but I just don't want I don't care, I want to bypass the warning about identifiers, like the one we're failing with right now. Well, you can turn off just identifiers, and I think we're still going to see that it's now going to complain about the method invocation, which contains that identifier. Oh, no. Yeah, that's fine. So I thought it might complain about that even though assertions was missing, that it might complain about assert does not throw. But in this case, just turning off the validation for identifiers and leaving all the other validations on is enough to get this test passing and bypass this failure, even though our class path is all messed up. Or right, even though the LST element coming in for this assert does not throw is now missing type attribution. But honestly, typically when you're turning off type validation, you're usually just going to say turn it off for everything. Just do type validation.none, opt out of this. And I really should go to that error message in the test framework and put some of this in that error message so that it is more actionable even to the good folks who do not attend or watch these videos. So that's a note for me to go improve that. Okay, so that is a common kind of mistake with Java template invocations that I wanted to cover. Let's see about debugging a recipe on some real code. Let's talk about how you do that, because this unit test is great, but a unit test is way simpler than the sheer variety of real code situations your recipe is going to run on. And if we're talking about running at scale, well, variety comes with scale. You're going to find the unexpected. So let's see about how to debug this recipe on some stuff. And so first I need to go find some places where this guy is going to be used. So this is remove, try, catch, fail blocks. Let's go see if this is going to have any results. I'm going to switch to running recipes on the Netflix plus Spring repo. Remove, try, catch. Let's see if we get any results for this. What's this? Recipes. Replace fail and try catch blocks. Oh, that's this one. I just didn't know it. It's right there in the results. I just didn't know what I was looking for. All right, so let's run this and see if any of the repositories I already have cloned down to my local machine are going to have results when I run this, when I try to debug this recipe. So it wouldn't be a very useful demonstration of debugging if there were no hits. All right, doesn't look like this particular recipe. Oh, I want to spring data couch base. There's one, but I don't actually personally have that repository cloned at the moment. Let's see. If I look at the Dev Center, are all of these projects already on JUnit 5? Yeah, almost all these guys are already on JUnit 5, so they will mostly already done this already. Let's maybe find a different example to work from. Let's see, maybe something else in rewrite testing frameworks. Oh, Netflix Mantis has a couple instances of this. Cool. Do I have Netflix Mantis cloned? No, I don't have Netflix Mantis cloned. Let's go clone Netflix Mantis real quick so I can locally run some recipes on it. Okay, that's annoying. I'm going to use the Moderne command line to go ahead and get this LST built locally. Kind of surprised it's not just downloading the pre-built LST from the Moderne SaaS, but that's okay. Let's see. So, but even if you're not using the CLI, and again, everyone can use the CLI thanks to that trial that I linked earlier, which, again, if you want to get in on trying out the CLI or the IDE plugin, you can go here. But even if you're totally just running your recipe with the Open Rewrite Build plugin, we can connect a debugger and step through a recipe. So let's see. So I am going to, because I'm initially going to debug with the Open Rewrite Build plugin, I need to modify this build to add the Open Rewrite Build plugin to it. So Open Rewrite Build, no, not Build Gradle plugin, Rewrite Gradle plugin. Let's see where we at. Latest is 6.15.1. And we'll add the plugins block. 6.15.1. Rewrite. Active recipe. We're going to set as our active recipe this guy from testing frameworks. This remove try catch fail blocks. Try catch fail blocks. See, did I get that right? It looks like I spelled that right, but just in case, yep, spelled it right. And I need to say, did you get this recipe from somewhere? Rewrite or open rewrite.recipe, rewrite testing frameworks. Let me get the latest one. I think that'll work. I just hit latest.release in the Gradle file. Actually, let's be explicit about what version we want. Latest version of rewrite testing frameworks is 2.10.1, 2.10.1. Okay, so let's see. Oh no, mod build had failed. Repository failed to build. Maybe because I was messing with it. So if I say gw rewrite try run, how do we do? Uh-oh, I'm having some problem building this repository. Oh, did I just type the version wrong? 2.10.1. Oh, latest .2.10.1. Oops, I only half changed the version to something correct. Let's try that again. I'm running into some compilation issue in this project. Oh, this is probably because I'm running on Java 17 and this project might still be a Java 11 project. That's fine. Switch back to... Fortunately, I'm on Windows, so I can't just use something like JInv or SDKman to easily switch around. I gotta mess with my bash RC, Netflix, Mantis. So let's see, do I have this in a situation where this is compilable now that I'm using JDK 11 to do it? Okay. All right. So it looks like now that we're running on JDK 11, everything is going to compile just fine. So I'm going to let this finish, and then I'm going to invoke the Open Rewrite Build plugin again to run this recipe, and we'll do it with debugging enabled so that we can hit a breakpoint. All right, cool. So now we're in a good place here. So let's do dry run again. Oops. Where that's coming from. Rewrite, dry run. And in order to connect to debugger or to Gradle that equals true to a running Gradle process, so this is not an open rewrite thing. This is a how you debug a running Gradle build thing. You pass in the system property, and it's going to start up a Gradle daemon, and then it's going to stop and wait for a remote debugger to connect. Maybe it already has. So let's see. If I go to Rewrite Testing Frameworks and I want to debug something about this recipe, I can stick, let's say we want to debug from this point on. I need a remote debug. And I already have this set up because I do this somewhat frequently. But assuming I was doing this from scratch, you'd go into your IntelliJ configurations or your preferred debugging tool of choice, select Remote JVM Debug, and it actually defaults to port 5005 in IntelliJ here, and that is the port that, if I'm remembering correctly, Gradle uses. So you see that compared to our previous build, this has just stopped. This has not gone anywhere. So let's actually go somewhere by connecting a debugger. And so we see that in IntelliJ, we've connected to the target VM on localhost 5005. And now that a debugger is connected, the build is resuming. So this is handy if you're ever debugging a Gradle plugin or anything that a Gradle plugin does, such as what Open Rewrite does. So let's let this go, and we have rewrite, dry run, resolving dependencies, and making sure everything still compiles, or more or less running compile again. And after this is all done and parsing has occurred, we're going to begin actually running the recipe. And hopefully hitting our breakpoint. But these processes take CPU cycles, so we have a minute or so to wait. All right, cool. We're finally into running rewrite dry run. Then now it has to go invoke the Java parsers and parse all of these projects. And then it will begin, once all of these have been parsed, which thankfully looks like it's not taking too long, it will get into actually running the recipe. And this process, the way this works when you run the Open Rewrite plugin, of it always having to parse through everything to build the in-memory representation of the LST, and then run your recipe is a downside of using the open source plugins versus using the Moderne CLI, which we'll cover next, because we keep the LST serialization and the code necessary to more or less build certain tools and services on top of Open Rewrite proprietary. So when you use the CLI, you can build the LST and save it off to the side and then run as many recipes as you want on it in succession. Whereas in the Open Rewrite plugins or the open source plugins, you're always reparsing the LST into memory every time, because in open source code, there's no direct way to serialize that LST to disk and keep it around between different executions. So there is an advantage to recipe authors as well as and recipe debuggers to using the CLI over these open source plugins. And obviously, once your project gets to a certain size, doing both the parsing and the recipe execution all together in memory, you may start to hit the limits of what's sustainable on your system and find that you do need to separate the LST production from the recipe execution in order to have desirable operational characteristics. Okay, so we're almost done parsing everything. 3 minutes in. Maybe we're going to start running our recipe in a second here. Come on, Mantis. You can do it. This is what I get for finding my first hit for the recipe. I selected more or less at random in a largish multi-project build. I have to spend this time parsing up front. Kind of surprised it's taking so long now that it's parsing the root project. It feels like it parsed all of the sub-projects quickly. I wonder if there's a lot of stuff in the root project here that is time-consuming to parse. Having a debugger connected can slow things down a little bit too, which is unfortunate, but just the reality of it. I had problems parsing a few files. Yeah, every now and then there's a performance issue with the data file. I've seen that we have some performance issues with parsing very large JSON or YAML files. So finally, 5 minutes into this process, we actually get to begin running our recipe. So in a case where this LST was already built, that 5 minutes would have been paid by a CI system. It wouldn't have been paid by us right now. But hey, look at that. Our debugger is connected. The recipe began executing, and we now have our recipe running against real code in this repository, and we can do all of the debugging things that we want to do. We can do things like, while I'm showing off useful debugging utilities, in a unit test, you already know the context of where your code is running. But I have, if I hadn't just run this recipe on the SAS, would have no idea what source file I'm in when this breakpoint is finally hit. So how do I go about orienting myself when I'm debugging against real code like this? Well, we've mentioned the cursor a couple times in this presentation alone even, and how you can use that to find where you are in a given source file, right? So we can evaluate expressions in IntelliJ's debugger just to orient ourselves within the source file we're operating on. So we can do things like, well, we're visiting a try right now. So, we can almost call jtry.print in order to, or any LST element, call print on it in order to render it as text and see, oh, cool, not too unexpected. We know that the recipe operates on this kind of thing. So it's not unexpected that we would see this in this case. So far so good, right? But I want to know, like, what method am I in, right? What source file am I in? Where does this snippet of code appear in context? And that's where it can be handy while debugging recipes to take advantage of the cursor. And if you've never looked at the cursor in a debugger before, it looks like this. You've got a cursor pointing, which initially, has a reference in its value to the element currently being visited by an open rewrite visitor, which is a j.try, obviously, and then a reference to the parent that contains it. And sometimes these parents are, a white space storing object like a j-right padded, a j-left padded, along those lines. But mostly you're going to be interested in, unless you're doing a white space or formatting related recipe, the parents that are themselves tree elements, the parents that are LST elements. So, I could say, like, well, I'm visiting a try. I want to see the method declaration that contains this try. So I could say, cursor first and closing j.methodDeclaration.class. If I evaluate this, well, now I found this locates the method declaration that includes the try. And I can print this out as well and see, oh, okay, the test we're running is this basic empty event filter test, right? This is where the try catch this recipe is operating on is located. Cool. Like, what source file is that in, though? So I could say, let's go to the first source file. And yeah, obviously, source file is the interface that j.compilation unit implements. And, here's the entire source file printed back out to text, event filter test. And I could also say, get source path. And it's like, okay, so this is under Mantis connectors, Mantis connector publish, source test, Java IO, blah, 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 event filter test. So you can use the cursor both programmatically and while debugging to orient yourself within a Java source file and get your bearings. And of course, you could, via the call stack, also scroll down in here far enough to find the parent elements of the current element. So, I could look up visit method declaration. And in here I would say, yep, here's where it's visiting, the event filter test. You go to visit like a type. I go to visit compilation unit and see, this is where, we're inside a lambda right here. You go up to this level and be like, okay, here's the compilation unit we're visiting, right? And here's that source path I found with the cursor. So because of just the nature of the visitor pattern, navigating up the cursor is a little bit like navigating up the call stack, but just oriented around LST elements in the visiting process. So be aware of these techniques to orient yourself while debugging. But anyway, so now we can step through this and do all of the fun debugger things that you might want to do, and go and work out all of the problems with this recipe as it might appear in real world code. So that's kind of how you debug with the Gradle plugin. I don't have an example on the tip of my I don't have an example. I don't think we have time to go into an example of debugging with Maven, but it works basically exactly the same, except instead, with Gradle, you add the system property, org.gradle.debug equals true. Unsurprisingly, Maven does not care about the system property, org.gradle.debug equals true. In Maven, instead, in the same directory where the Maven executable itself is located, there's a sibling executable called Maven debug, which runs Maven, but waits for a debugger to connect right at the beginning in order for you to connect a debugger. And so that works, aside from how you invoke the tool, it works the exact same. I think Maven debug starts on a different port, but it'll tell you, it starts on port 8000. So, Maven hasn't even gotten far enough to say, this isn't a Maven build you've invoked me on before it prints this out. But that's not going to go anywhere. So we'll just cancel that. Okay, so let's see if I have enough time left. to get a Moderne CLI recipe run going. Unfortunately, I didn't have this project built in advance, so we might run out of time before I can show this off. So, yeah, this is probably going to take about 5 minutes, since that's how long. Since this is going to do parsing to build this LST and write it to disk, and thereafter we would only have to we could rerun the recipe as many times as we wanted without paying that parsing cost. But I just did not budget quite enough time today for that. So through the Moderne CLI, once you have the LST built and you're running the recipe, and you say, mod run recipe, this try catch block recipe, you just say, add a JVM debug argument, and it would work exactly the same. It would pause and wait for the debugger to connect and before running the recipe, and you would connect in your IDE and have access to all of the same tools and techniques that I've been covering so far. So I guess we will just leave it there for today. I hope that this was valuable to you, and I wish you great success in building and debugging impactful recipes that will help move your software engineering organization through its various tribulations, trials and tribulations, and into the future. Until next time, I've been Sam, and I look forward to seeing all of you in our Open Rewrite community Slack and at my No Fluff Just Stuff webinars tomorrow and Friday. So goodbye until then.